ஆடியோ இன்புட் தானே சார்? அப்புறம் ஒரு நிமிஷம், நீங்கள் இந்த வீடியோ இல்லை, நான் ஒரு ஓட்டோ தேங்க்ஸ் ஒன்று வச்சுருக்கேன். அதுக்கு நீங்கள் என்ன பண்ணணும்? வீடியோ இல்லை, அது இதுதான், ஆடியோ தான். இது மீடியாவில் போயிட்டு
Very good afternoon to all the participants. I am Dr. R. Govindarasu.
இப்போ டிஸ்பிளே வர மாட்டேங்குது வீடியோ. இப்போ பார்த்தா வந்துச்சு, நான் செட் பண்ணி வச்சுருந்தேன். இப்போ பார்த்தோம்னா பாரா. Hello, testing. Hello, testing. So good morning to one and all. First of all, I apologize for the late delay. This is some due to some technical issue in streaming software. That's why we're having some delay. Oh, sorry, we are having almost 40 minutes delay. Okay, so I extremely sorry for this one. Okay, I directly go for this session, today's session. Yesterday, what we discussed is the Matlab applications, in which we discussed about histories and some basic commands in Matlab. Those things we discussed in the previous session. Today, I start with um, so So, good morning to the participants. I once again welcome to today online workshop on Matlab applications in process simulation and control. I welcome to the day 2. Again, once again, I am Apologies for this too late delay. Okay, today we go for the second session. Okay, I start with built-in functions to characterize vectors of the elements. Okay, so previous day I told that there are so many built-in functions are available in the Matlab. If you want means you can write the functions according to your wish, or otherwise you can use the functions already available in your Matlab. Okay, actually in the very first I told that it's somewhat similar to the cooking. If you want to do the cooking means you need not to be do all prepare all the things. Okay, what you're going to do, just you have to get the some ready-made items from the grocery shops. Likewise, some functions or some library programs are already written by someone. Just we are going to be make use of those functions or libraries, how to make use of them and make it as an we have to make the program very easy to write the program. Okay, you can see here these are all the some built-in functions which make it easy to perform the variety of mathematical or statistical operations. Okay, so for you can see this is a sum, product, mean. I think from the name itself these things are clear what it does. Like the at only they designed this one, and we are having some trigonometric and hyperbolic trigonometric functions are available, special built-in functions. These things also I already told in the previous class, and we are having for the real numbers the factor, GCD, LCM, round, seal, and floor. These are all the things available, and length, min, max, mean, median, standard deviations. And one more thing, some built-in logical functions valued as 1 when true and 0 when false. Sometimes you have to check, is it prime, for the status of the prime number. If you want to check whether out this prime means, if it is true means it is going to give the answer 1. Based on that you have to take some results. If it is not the prime number means it is the 0. Likewise, is it real or is finite, or the result is the infinite, something like this. Okay. Then the polynomial and regression functions. So convolution, CONV computes the product of the two polynomials, deconvolute, eigen, polynomial, polyfit, and fits the polynomial to data. Polyval evaluates the polynomial and generates the error estimates. Roots computes the polynomial roots. Likewise, we are having the size, determinate, rank, and we are having the trace, eigenvalues, FFT, IFT, and logarithmic. These things are available. And you can see here the vector functions. This is the operate on the vectors returning the scalar value. One more thing, this is the b is the vector, we are getting the maximum value, a maximum value, length is you can see here. Before that, a equal to, this is the one of the built-in function, link space of x comma n, or otherwise x comma n comma n. It is going to generate a row vector of 100 linearly equally spaced points between x1 and x2. If you are not giving any value n means in default it is going to be generate the 100 linear paths, or otherwise if you just I want to generate the some points in between x1 and x2, just 10 points means I have to give this one. Now you can see from 0 to 2 pi is divided into 10 equal parts. 0 to 2 pi is divided into 10 equal parts. That is the a, that B is sine of A. B is sine of A. For each and every value of these things, it is going to be find the sine. So A is this, B is this. 0.6, that is between 0 to 2 pi, the 10 values are generated. For each and every value, the sine function is determined and it is stored in the B. Now, what I am going to do, I hope that you understand what is the speciality of the linspace command. Okay. Now let us go to some plotting functions. Okay. So you can do the plot function is used in different ways. Plot of data. If I am giving the only data 10 data means it is plotted by the samples. For 0th sample, what is the data? The data are considered as from for the y-axis. This is for zeroth value, what is the data, first value, what is the data. Likewise we are having plot means x comma y, as usual you already know about this one, and plot of data comma some parameters. It may be a line style, color, point style. We are going to be define these things. The color is RBGCKY, and the point style is, it is the plus or asterisk or into mark, 0, greater than, etc. These things are available. And the line style is dash 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 dash. Okay, so we can give like this. Now I am giving some basic plots. Audience, are you able to hear my voice clearly? Please reply in chat box. I'm not enable my video. It's the PowerPoint plus my audio only. Audience, you can hear my voice clearly. Please reply through chat. Okay, I hope my voice is clear. Okay, you can see the plotting function. The x equal to 0 to 2 pi. Here, don't confuse with linspace and this one. The linspace means from starting and ending you have to give the function. Here, what I am going to do is, this is the start and this is the end. This is the step size. What you are going to do, from 0 to 2 pi, in the steps of point what, it is generating the data and put it in x. I am finding the value of y and plotting here. You can see the red color, x and y are plotted. It is the dot and the style is the dash. If you want means you change the colors and so many things like that. Same thing, what I am going to do is the plot the function sine of x between 0 to pi. Okay, they create X arrays of 100 samples between 0 to pi. Here they are giving it as 100 samples. Now I am going to be use linspace x1 comma x2, that is 0 to 4 pi. I already told that the pi is the function which is available, constant which is available in the Matlab itself. So n, it is going to be given as 100. So what I am going to do, x, now from 0 to 4 pi, it is divided into 100 equal parts and stored in x. What is the y now? I have to find the sine value of the x. Now I am plotting x. Now if you want to give the title, means you can, function is title of within quotes given name, it is the sine function. You can give x label, you can give the y label. You can see difference between the previous one and now is that there is no title x axis and y axis. But now after giving these functions x title, x label, y label, you are getting the titles and x values and y values. Okay, you can see here. Again, one more example. The plot the function e power minus x by 3 sin x. E power minus x by 3 sin x between 0 to 4 pi. I am using the same x, y equal to sin y. I am calculating this part alone. Y1 I am calculating exponential of minus x by 3. After that I multiply y and y and y1. I have to store it y2. Now I am going to be plot the values between x and y2. X and y2. You can see here. This is the plot for this one. Okay. Now similarly we are having same thing. Instead of this is, I am using the line space. Previously I didn't use the line space here. Here in this function I am using the line space sine plot y and plot xy. What is, you can see, if it is the plot y and plot xy, the plot x means it is divided into 100 equal parts, it is taken as the x. Then one more thing, the stem is the available. Stem means from the name itself it is the clear. It plots the data sequence y as stems. In, you can see here, this is the stem of y. Okay. What is the line space? I already told that the line space means somebody asks. Line space means it generates n points between x1 and x2. If you want means you can put 10 or 100 or 500, whatever it may be. Okay, you can give here. That is called the line space is the function most widely used for the plotting. You can use one. A new thing in next one is the stem. The plots the data sequence y as the stems from the x-axis terminated with circles for the data value. In the y-axis, it is terminated with small circles. It looks like the stems for each and every values of the x. The amplitude is going to be in terms of steps. Okay, now you can see you are having the matrix of 3 columns and you are having the 10 rows. The Matlab will treat each column as the different sets of data. It is going to be treat it as the first set of data, second set of data, third set of data. You can see for the x-axis 1, it is 0.1. X-axis 2, it is the 0.4. 3, it is 0.3 like this. So 1, 2, 3, 4, 5, 6. So the final value is zero point 0.9, zero point 0.8 and zero point 0.4. So it is going to be the plot between, just I am giving the plots and results. So the x-axis is taken as the 10 numbers, the samples, zeroth sample, first sample, not zero, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. The y-axis values is going to be like this. This is for the plotting the matrix. Okay, you can see here, this is another one, x, y and plotting. One more thing you can see here, I am giving the new command here, legend. Legend sin x for next one, the 2 into sin x. The first one is plotting the sin x, second one is plotting the 2 into sin x. Okay, so the same thing I'm finding the x and y. Then I am multiplying with the 2. That's why the y is the new thing for you. Okay, so you can see here plotting the multiple data sets in one graph. So x is 0 to pi by 100. Sorry, from 0 to 2 pi it is divided into, in the step size is pi by 100. Y equal to sin x, y2 equal to sin x minus 0.25, y3 equal to sin x minus 0.5. Now for a value of x, y, y2, y3. Now I am going to be plot the values between x and y2 and x and y3. So what happens here? You can get the 3 different plots in the same graph. Okay. So if you want means you can go ahead with the different values, y1, y5, y6, y7, whatever it may be. Okay, so this is how to plot the multiple data sets in the one graph. Okay, so then likewise we are having the mesh and serve are the two commands inbuilt functions available. The mesh x, y, z creates the mesh plot. Both the things they are used for the three-dimensional surface plotting for the three-dimensional. Wherever you are having the x, y, z, we are using this one, which is a three-dimensional surface that has a solid. I will give an example for this one: solid edge color and no face color. Whereas surf is the another three-dimensional surface plot, which is the three-dimensional surface that have solid edge colors and solid face colors. Here there is no face colors is not given in the mesh. Here it is going to be given the solid face color. The function plots the values in matrix Z as height above the grid. In the xy plane define x and y. The edge colors vary according to the height specified by Z. Okay. Now you can see one more thing. The new thing what I introduced here is the subplots. Okay, what is the subplot in here? You can see here. That is the difference between the previous one. What I told in the previous, in a single graph, I am going to be plot various pairs of xy arguments, create the multiple graph in a single plot. But the plots are separate plots are separate but in one figure. Most of you seen these things in books or some technical papers like these things. So what happens here? Subplot m comma n comma p. These are all the arguments I have to pass. This splits the window. Which one? Subplots. Splits the figure window into m by n matrix. If I am giving 2 comma 2 means 2 rows 2 columns is going to be split of small subplots. This is the plot number 1, this is plot number 2, and this is plot number 3, and this is plot number 4. Okay, I once again giving you can see this one. This splits the figure window into an m by n matrix of small subplots and selects the p subplot for the current plot. For example, you can see here t ranges from 0 to 2 pi. The step size is 3.14 divided by 10 x y z. There is one more command called cylinder. It is going to be make the cylinder 4 into cos t. Okay, you are having getting the values of x, y, and z is available here. Now I am going to make the subplot 2 comma 2 comma 1. That is, our plot is divided into the figure window is divided into 2 by 2, that is 2 rows and 2 columns, in which the first figure is the mesh of x, second figure is mesh of y, third figure is mesh of z. This is one. After dividing this by 2 by 2, we are going like first 2, 3, 4. Mesh of z, mesh of x, y, z. Instead of this, if you want means you can give plot x, plot y, plot z, plot of x, y, like that. You can give. Okay, here you can see here. So some of the plotting functions, I'm consolidating here. The plot means create the plot figure, define the new figure or plot window. Then grid off is another thing is available. Create the grid lines, that is checked lines in a plot, title, x label, y label, and axis, hold off, legend, subplots. Okay, so these are all the things. Example for the plotting. You can see here another example. So the Monday, Tuesday, Wednesday, we are having the rain values. These values are stored in x. Then I am plotting of x means what happens for the day 1 it is 2.1, for day 2 it is 10, for day 3 it is 9.7. Yet this is just a plot of x. I am putting the 0. The style is 0. If you want means put x or asterisk, whatever it may be. Okay, just I am giving the plot. This is for 1, this is for 2, this is for 3, this is for 4, 5, 6. Okay, so the x axis is 1, 2, 3, 4, 5, 6, 7. The y axis is this amplitude 1, 2.1, 10, these things. So this is another example for the plotting. You can see here the some subplots, x equal to 0 to 2 pi. In the intervals of 0.1 I am dividing and store it in x, y equal to sin x, y equal to cos x. I am giving the subplot. Previously what I done is by using the sub commands I am plotting some 3-dimensional figures. Here I am doing the 2-dimensional. This is nothing but by x and y. Somebody told that the now it is visible. My PowerPoint is visible to you. Tamilmani told that the PPT is not visibly clear. Now I am zooming. Maybe some depends upon the font size and background color. Sometimes it may not be visible. I hope now it is visible. I will zoom it whenever the font size is smaller. Okay. You can see here a subplot of 2 rows, 1 column. You can see this is the output. We are having 2 rows, 1 column. This is the row. 2 rows I created in a single column. If you want means you can put 1 comma 2. That is what happens. 1 row, 2 columns. It is doing like this. Your figure is, it is the figure is, it is dividing like this. If it is the figure 1 here and figure 2 here. Okay, if it is 1 comma 2, the first plot here and first plot, the second plot here. Since it is the 2 by 1, that is the 2 rows, that is rows, this is row, and one column, it is the one column we are having two rows. Okay, so the subplot you can see here, x is 0 to 2 pi. In the intervals of point 1, I'm calculating y, y2, y3. Subplot 3 comma 1, 3 rows, we are having 3 rows, 1 column, we are having 3 rows and 1 column. You can interpret like this. If I am putting 1 comma 3 means, what you are going to do, it is like this, the figure 1, figure 2, figure 3, it is going to be like this. Okay, now you can see here 2 comma 2, your figure is divided into 2 rows, 2 column, p equal to 1, p equal to 2, p equal to 3 and p equal to 4. Okay, these are all the examples for plotting. Okay, so you can see here another example. After plotting y z, you can see plot xy blue in color, xy in red color. Okay, the plot x label x values, y label y values, title, ledger, and grid also I make it as an on. You can see here the plot the following function: y equal to t, the t varies from 0 to 1, and 1 by t from 1 to 6. So the t1 equal to line space of 0 to 20 in the intervals of 1, t2 equal to line space 0 to 20 in the intervals of 6. So y1 equal to t1, y2 equal to 1 by t2. I am plotting this one. Okay, now how to divide the t equal to t1 comma t2. I am creating the one matrix here, y equal to y1 comma y2. So I am plotting t comma y. Now the t comma y, you are getting the plots like this. Okay, again this is another example for subplots, and we are having the legends x-axis and y-axis like that. Then syntax for the subplots, I already told this one, and attributes for the plots also we already discussed, and we are having the plotting the polynomial. Okay, you can see you are having the polyval is the function returns the value of the polynomial a evaluated at s. P is the vector of length n plus 1 whose elements are the coefficient of the polynomial in descending power. So you can see this is the function s equal to line space of 5 comma 5. It is divided into 100 equal parts. Minus 5 to plus 5, it is divided into 100 equal parts. The coefficients are 1, 3, 3, 1. Okay, I am making the variable, the coefficients are, you can give x, y, z, whatever it may be. It is 1, 3, 3. A equal to polyval of coefficient comma s. So it is going to be evaluate, give the values to these and calculate a. I hope what I am saying is clear. The polyval returns the value of a evaluated at s. S is defined here. Okay, within minus 5 to 5, I am divided into 100. So for 100 values of s are available. For these s values are substituted here and you are getting the a value. Now it is plotted between s and a. Now you can see here it is starts from minus to 5. We are having the 100 values. It is plotted versus the newly evaluated value from polyval s versus a. So we are having x label s and y label a of s. Now we are having one 3D plot. As I told earlier, it is the x, y. Somebody told that. Okay, now Now is it clear? So x is from 0 to 10, y is from 0 to 10, z I am calculating x dash into y. So I am giving the 3D plot by using the mesh x comma y comma z. Now you are getting the values of 3D graph x, y, z. Just I am giving the title as and the 3D graph. Now you can see the equation of sphere. I am plotting it as for the equation of the sphere. So you are having x square plus, this is the equation of sphere, x square plus y square plus z. Vertical coordinate x and the polar coordinate is theta in xy plane or the parameters. Okay. So r square plus z square equal to 1. I am calculating the r, x and y. Okay. R, x and y. Now I am going to be plot the theta equal to z equal to mesh grid of 0 to 2 in the intervals of 0.1. Okay, so x equal to I am calculating, y equal to I am calculating, I am giving the surf. It gives the phase value also here, whereas in your mesh the phases are not clear. Here sorry, there is no phase, but here we are having the phase. This is the example for mesh and surf. This is surf, and same thing I am using the mesh. If you want means you can give the bar graphs also. 0 to that is x equal to minus 2.9 to plus 2.9 in the intervals of zero point 0.2. The command is instead of plot, surf, mesh, we are having the bar is available. X comma minus x dot x bar. Okay, so okay, next let us pass on to the flow control. Okay, this is while writing the program, whether in Simulink or in M file commands, these things are very important. What are the flow controls which is available in the Matlab is if else or if else if else, switch case, otherwise loops. These two are flow control, and these two are loops. This is for loop and this is while loop. The behavior is same as in the other programming languages. I think you know about in C, C++, we are using the flow control and loops. Okay, there we are having the while loops. In Matlab also we are having the while loop, for loop, if else, switch statements. In other languages the same, the syntax only it is going to be differs. Okay, how the syntax you can use it in the Matlab, we can go through with some simple examples. Okay, you can see if, for, while. This is the if statement syntax. For example, I am giving if the condition, whatever it may be the commands, you can give the commands a plus b, a minus b, or c equal to exponential of minus 2, something like that. Else if, you can give another condition, you can do some operations. Else if, else if, else if, you can go like this. Final thing is not else if, is we can give else. Matlab commands. It is this control structure is ended with the command end. You can see some examples. Just I am giving if and end. I am checking the condition. If a is greater than, if a is greater than 3, I hope you remember this symbol. This is for the AND operation. In the previous class I told that. And this is also you can, the b is equal to. If it is a single equal means I am assigning the value 5 to b. This is a logical operation. This is the thing. Just if the condition is satisfied means these following commands are executed, or otherwise the command is not executed. Go ahead with the next instruction. You can see here if a less than 3, some Matlab commands. Here I am checking the another condition. Sometimes if a is less than 3, for the remaining all conditions have to apply some commands means you can directly put else. But here what I am doing is else if b is not equal to 5. So some Matlab commands you can write here. The finally, as I told you earlier, if a is less than 3, some Matlab commands, else some Matlab commands. Here you can see here some difference between this Here I am checking the another condition. After that only it execute. There are two conditions, but one condition. If the a is less than 3, execute. For the remaining whatever it may be the value of the value of a. For all the values it's equal to 3 and greater than the values of 3, it is going to be execute this command. This is for the if else. Now you can see this example. I hope this is clear. Anyway I am zoom it because since I directly cut and copy it from the Matlab software itself, sometimes for this reason some fonts may break here. Okay, so I hope you know what is clear all clear screen and x equal to input. Actually the input is the another function. It is gets the value from the user. I hope you understand it in C in and scanf you are using in your C or C++ to getting the data from the user. So it assign it in x and assign it in y. Whatever it may be the value within the single quotes, it is displayed here. Now I am checking the values of x and y. If x is greater than y, if x is greater than y, just disp is similar to cout or printf. Cout or printf in your C or C++. What's the conclusion you are coming? X is greater than y. Else if else is x is less than y, it is going to be display y is greater than x. Else what may be the another condition? Disp x is equal to y. So it is the some simple example. Here instead of disp you can do any arithmetic operations, or within the thing again you can put another loop also, or you may put some plot commands, or you may execute some other functions. Whatever it may be you can do it. Okay, so this is for the if else command. Next one, the same thing. I think I skipped this one. This program is used to solve the quadratic equation. So we are having this one. I'm getting the values a, b, c by using the command input. I'm getting, and d is the minus b minus 4ac. If it is 0 means we are doing this one. Non-zero values means minus b plus root of d divided by 2a. You are going to be do. For this, I'm writing the program. You can see it is a very simple program. Participants, actually since we are having the more commands here, better you can store the program in m file. If you are having the 2 or 3 or 4 commands means you can enter it in a command prompt itself. Whenever you are using the loops, if you are having a set of commands you are having more means, better you can store it in m file and you can run it. At the end if you want means I will show some sample programs for the m file how to run it. Okay, don't bother about this one. So you have to go to the editor, go to file and new, and you can type the program and you have to save it as a quadratic.m. Okay, then you can run it from the command prompt. Quadratic it is running, or otherwise there is small run button is available in the top of the window. You just if you are clicking that one means from the menu also you can run the program. Okay, so just since it's a very big program, not big one, we are having the 18 lines is available. Better you can store it in the that is programs, that is file. So we are having the first one is clear all, and just this is for understanding. And this is ax square plus bxc. Then I'm getting the 3 values and computing the d value. D is 0 exactly. We are calculating the x like, that is the equal roots. Then x equal to x1 equal to x2. Then else you can see here I'm getting the value. I'm using the if else end. Else means you can use x1 and x2. You are calculating. It is the distinct roots, and I am calculating. I am displaying the values. Okay, so this is for this one. Then another one, the control structure, the for loop, the for I equal to index array. It may be 10 or 20. I think I hope you come across the for loops in the C. In the C, what you have done for I equal to 0, I less than or equal to 10, I plus plus, something else like that. Okay, so here we are having, there is no incrementer operator here. It is auto incremented by 1, or otherwise you can manually incremented in the inside the for loop. Okay, so this is the thing. So you can see some dummy examples. I will zoom it here and show it to you. For I equal to 0 to 100, some Matlab commands. So 100 times it is going to be iterate this loop. Same thing, I equal to, sorry, j equal to 1 to 200. You can see the difference between this and this. The step size is 1 here, but the step size is 3 here. 1, 3, plus 3, then plus 3, plus 3. So, if I am not putting the 3 means it is running 200 times, or otherwise it is running there, this divided by step size time only it is going to be done. Running. Okay. So, you can see here for m equal to 13 to minus 21. So your step size is minus 0.2. So 13 minus 0.2, 12.8. 12.8 minus 0.2. Likewise, it is going to be going in the reverse side. So the last option you can see, don't think that always you must give the range. So here I am defining some k values also. For k equal to 1, it is running. K equal to 3, it is running. K equal to minus 13, k equal to 12, k equal to 7, k equal to minus 9.3. For these 7 values, so it is used the k values inside this command and it is going to be execute the output. Okay, you can see one more example, and is input the enter any integer. Just you can give sum. I am initializing it as on the 0 for I equal to 1 to 10. For example, if you are giving n equal to 10 means the loop is running for 10 times. For I equal to 1 to 10, sum equal to sum plus I. Initially the value is 0 here, I means it is the 1. So 0 plus 1, 1, it is stored in 1. The next one is the 1 plus 1. So I am finding the values of 0 to 10, that is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. So for this I am using the for loop. I hope everybody knows about how to find the factorial of 5. Okay, so n equal to 5, f is the another variable in which the factorial of the 5 is going to be stored. That's why I am initializing it as the 1. So already the since I starts with 1, the for I equal to 2 to n. From 2 to n it is going to be doing the 5 f equal to the for loop it is running. It starts from the 2, the I value. So 1 into 2 is 2, it's stored here. Then now the I and the second iteration the I becomes 3 and end and display f. So the factorial of 5 is displayed. Okay. Then you can see here, it's a very nice example. Here we are integrating the subplot and the for loop here. Okay, what do you understand from here? Just you can go through. If you want, I can zoom this also. X starts from minus 1 to 1. The step size is 0.05. The for loop, I am going to be put 1 to 8. That means 8 plots I have to do. 8 plots. So I think you remember the subplot equal to rows, comma, columns, comma, p. For example, this is 4, this is 2 means, what is the meaning for this one? We are having 4 rows and 2 columns. 4 rows and 2 columns. Okay. This is the 1 means the first display is here. For n equal to 1 to 8, subplot 4 comma 2. So your window, the figure is divided into 8 subplots of 4 comma 2. Here 1 because the for loop here running is 1. Plot x comma sine of 1 into pi into x. Okay, so it is running and it is plotting here. Next one, it is, you can see the frequency here. I am increasing the frequency here. So 2. This is also multiplied by 2. The plot is also varying. The position of the plots where in the figure it is also varying. Next 3. This is 4. This is 5. Fifth figure 6, 7, 8. So totally we are having 8 figures. Okay, I hope you understand this one. This is for the for loop. Sorry, I actually in the previous by mistake I told that the double equal to is the that is the relational, that is logical operator. Okay, sorry, actually this is the relational operator. Okay, by mistake I told this one. Okay, sorry for that one. And then commands we can use this one, and I hope we already discussed this one. And the same matrix. You can see here the matrix operations. I am using the for loops. Here, what's the new one is I am using the two for loops. The one is the outer for loop and another one is the inner for loop. This is a row comma column. A row comma column. 1 divided by 1 plus 1 minus 1. Some operations I am done here. Don't bother about this operation. This is stored here. 1 comma 1. Next one. This is 1. This is running, inner loop is running 3 times. 1 comma 2. Then this is 1 comma 3. Okay, I hope you understand. This is 1 1. This is 1 2. This is 1 3. This one and this is the inner for loop, and this the common one, this and this is for the outer for loop. Okay, next one, this is 2, it becomes 2, and again it is having the inner for loop is running for the 3 times. I hope you understand this one. Then while loop syntax, while condition, Matlab, and you are having the end. You can see while a is greater than 3 and b equal to 5, some commands you can give, and this is the end. So here I am giving some example how to generate this triangular formats by using the while loop. I am initializing a as an 1. If length of a, now initially the length of a is 1 only, less than 10, condition is satisfied. So a equal to 0 comma 1 plus 1 comma 0, that is 1 1 is stored in a. Okay, now what happens, the length of a becomes 2, still it is less than, the condition is satisfied. Then we are adding, and it is the results are showing. Since I am not putting the semicolon, the results are executed in the command prompt. And one more example, EPS equal to 1, counter equal to 0, EPS plus 1 is greater than 1 means counter equal to counter plus 1. Some Matlab commands I am giving here. Okay, this is the condition is satisfied means finally the counter equal to 53, and we are having the both the values we are having. Then finally we are having the switch case construction. Okay, so what is the switch case constructions? Switch some expressions we are giving here, and case test expressions 1, case 2, and case 3, case 4. Finally we are going to be giving the otherwise. Okay, so example, you can see the method you need is bilinear. This is the input you are going to be giving, or it may we are got it from the previous subparts of the program or in sub functions. Switch is method, it is a dynamic one, it is dynamic, the method is a dynamic. Okay, so the case linear means you are going to do some operations. For simplicity, I am giving it as the disk, the method is linear. If it is cubic means method is cubic. Otherwise, case 1, case 2, if you want means you can go ahead. Otherwise, the unknown method. So similarly, I have to put end also. Okay. So if I am giving the method equal to bilinear means what happens? Is there any cases available for the bilinear? That's why it is display it as, and the method is unknown method. If you are giving the linear here, if you are giving linear here means it is displaying the method is linear. Okay. One more thing you can see here, most of you come across sometimes when you are entering the password in your system, it shows that error or check your password, something else like that it is showing. You can see this program, clear all, close all, clear screen you can do. We are having for I equal to 3. Why I am giving I equal to 1 to 3? I am going to giving the 3 options only. I think in your mobile banking or in ATMs, they are if it exceeds the 3 times means what happens? Your password is locked or something like that. So in the first iteration, x equal to input, please enter the password. It is taking it as on the string. Switch, it is converted into lower of x. Case, if it is computer, that means assume that your password is computer. In message box, it's welcome. Break, it comes out from the loop. Or otherwise, error dialog message is displayed. Try again. How many times you can try again? Not more than 3. Okay, so that's why I'm putting the for loop here, in which internally I'm putting the switch case. Why I'm putting the break? If the condition is satisfied within the 3 chances, the condition is break. That is, it comes out from the loop. Okay, this is also another one. We are having the A B vectors, and display is, if we are pressing 1 means add, 2 means maximum value, 3 means diagonalization, 4 means exit. The n you can get it from the user and store it in n. So if n is not equal to 4, you go inside. 4, since 4 means it is exit. That's why I'm putting the 4 here. Switch of n. 1 means a display of a plus b. Okay, display of a plus b, max of n, and diagonalization of the b. Okay, so for if I am putting the end, 2 ends I am putting for the if, and switch I am putting the 2 ends here, since I am putting the 2 loops. So this is another example for the how to create the matrix of 3 by 3. Matrix of 3 by 3, but it is not needed here. Just for example I am putting here. Okay, so, and this also we already discussed. I am skipping this one, and this also we already discussed in some other way I am giving. That's why this is the flow control for loop we already discussed. You can see here, we want to find for what value of x the function has its lower, the minimum of the function I have to find out. The minimum of the function I have to find out. This is the thing most of the times you come across. You can see here, this is the x vector is minus 20 to 20. The y I am doing this one, the polynomial. 2x square plus 20x plus minus 22. Okay, it starts from I equal to 1, while y of I means y of 1, the first value, what it is calculated, is greater than the next value, means I equal to I plus 1. So, if as long as the condition is satisfied, this loop is running. Otherwise, it comes out from the loop, that is the lowest value. So, up to this, the condition is satisfied. Okay, because this value is smaller, this value is greater. Smaller, greater, smaller, greater. But from this point onwards, it is ulta. The first value is smaller, second value is greater. That's why it comes on from the loop. It gives the, what it gives? Minimum of the function. This is the value. It gives the minimum to this function. Okay. This is another example. Okay. This also we already discussed. I skipped this one. I'm skipping. Skip these things. I forgot to tell this in the beginning. As I told, you can see how to create the M file here. Go to the file, and we are having the new is available, and it looks like the window looks like it is the extension of the M. If it is the Simulink, means if it is the extension of the MDL, the text file contains a script or function of the program to run. Okay, in which you are going to be run this one. So you write the program and save it, and you can see the I am giving it as in the denem430.m. Okay, so you can see here likewise I am giving this one, and we are having the some symbol for run is available. This is one of the older version. The newer version, it is a symbol like run. This is available, or otherwise go to the tools and you have to run the programs. You can see. That's why I'm giving the one newer version also, because somebody are having the Matlab older versions and newer versions. That's why this is the 15A version, in which you can go to new, and the upper part is like this. The upper part is somewhat differs. New, you are getting like this. Then you can save it and give the name and finally run the script by using, this is a script editor. You may create the various lines of the codes and execute all the lines in single batch. Okay, then if you want means you can do some changes and create or add or delete some commands while you are storing it as and the scripts. Not it, if it is in commands means it is not possible to rerun that one set of commands. That's why we are doing this one. Okay, so this is the thing we are running and we are giving .m as usual. Then you can see okay, so up to this next I'm pass on to next very important topic. You can see this topic itself. It is user defined functions. Why I'm telling is because so far we discussed about the built-in functions. You can see built-in functions. Now you are going to create your own function according to your requirement. Sir, this is my requirement. For this, there is no such function, built-in function is available means don't bother about what. Now, so far you know what are the commands available, what are the built-in functions available, what is the syntax, how you are going to make the file like that. So, you can write it and make it easy a function, then you make use of that function in the due course of the time in your programs. So you are creating your own function now. For this, how you are going to be write the user defined functions. So again, the functions are M files which can be executed by specifying some inputs and some desired outputs. The input may be a 1 or 2. The input may be 1 or 2. Sometimes more than one. Two inputs, one outputs, two outputs, one input, whatever it may be, the combination depends upon your requirement. This one, okay. That code telling the Matlab that an M file is actually function. You can see the function is the keyword, out is the function name. Okay, sorry. The out is the output you are going to be stored here. The function name is here. Okay, this is the input variable and this is the output variable. Single input, single output, three inputs, two outputs, two inputs. Okay, you should write this command, in the beginning of the M file. I will give an example later. In the first line of the function is this one, and one more thing, the function name. For example, the function name is temple. Okay, the same thing is given as and the name for this file. Understand or not? What I'm saying is you should write this command in the beginning of the program and you have to save that M file, that is script file, as the same as the function name. Okay, so this is the thing, you have to make it as an the very clear. So the name, input, and result means this is the output, this is the function name, this is the input, and this is the result, and actually this is the name, and the x is the input. I hope you understand this one. Actually the cause is the built-in function. Just for example, I'll say only I'm giving this one. Okay, this is the word function, must be the variable that defines the output and the variables. This is the poly is the function name. The function is the keyword. This is the keyword. This is the output. This is function name. Okay, the variable. The final one is the input argument. This is the input argument. Okay. Now write the user defined functions. You can see here I'm going to write the function. The out is the variable squarer a comma int, which takes a square of the input matrix if the input indicator is equal to 1. If it is 1 means it does the square, and it takes the element by element square of the input matrix if the input indicator is equal to 2. Now you can see here this is the function I wrote. Now function is the keyword, out is the output variable, squarer is the function name. It must be coincident with the file name also. Here this is also square and this is also square, and and you can see A int. A is the matrix in which the A is the input, it is coming. 1 is also input, it is coming from the other program. If int equal to 1, if int equal to 1 means out equal to A power 2, that is square of the input matrix. Else if int equal to 2 means out A element by element square of the input matrix. Element by element of input matrix. I hope you now is clear. Same name, squarer. The squarer is the function name that you can use like plot. You can give pow, square, rank, max, min. Likewise, you can give the squarer. You can call it from the other programs also. These two are the inputs and this is the output. Now I hope you understand with this example. Another function, I will zoom it, which takes the input array and returns sum and product of the elements as the output. Now you can see the function, two outputs. I am giving the name as an sum pro array. You can see here, this is also sum pro, this is also sum pro. First output is sum of the array. Second output is product of the array. Now you can see from the command window I am doing this one. R equal to 1 colon 10. Output 1, output 2 equal to sum product of R. What happens? Now sum product means it is the function. So now this program is called, and what is the input you are giving? R. We already created the R matrix, that is the vector 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the value coming to this program. So it is stored in array. Then out 1 equal to sum of array, out 2 equal to product of array. Now out 1 equal to 55, out 2 equal to, this is the product. I hope you understand. Here I am return the function. Now from the command I am executing this one. Now the R goes to array. This is the out 1 and this is the out 2. Now you can see here we are having the simple function, another function, output equal to poly of x. This function calculates the value of the third order polynomial. So the x is the value taken from the some other programs, and it is calculated here 3x cube plus 5x square minus 2x plus 1. The function name must be as same as the file name, as I told you earlier. You can see in the second one, poly of 4. So 4 is the variable passed to here. This program is called, the poly.m is called, x is passed to here. It is calculated and the output is stored here. Okay. So from the command window itself, I am running this function. Okay. These are all the some other things available. Function f. Okay. Function, it is up to accept the numerical values, variables, scalars, and arrays. You can see here, I am zoom it. Results equal to f of x. The function name is f. F of 60 you are giving means 60 dot divide by 60. Okay, so 60 by 60 you are getting the 1. If it is x equal to 1 by 10, I am giving some series of values. F of x means 1 divide by 60, 2 divide by 60, 3 divide by 60, 4 divide by 60, 5 divide by 60, and so on like this. This is another function. The function with multiple inputs. We are having the two inputs here. Okay, and g of x comma y, two inputs, one output. Two inputs, one output. Okay. With multiple inputs. If you want means you can increase the x, y, z, a, b, c, d, something else like that. X equal to 1 colon 5, y equal to 5 colon 9. We are creating x equal to 1, 2, 3, 4, 5 and y equal to 5, 6, 7, 8, 9. Now I am sending this one. I am calling the function g and x and y are the inputs. X and y are the inputs, and this is calculated, and a is the output. The values are stored in the output a. Okay, this is the thing for your multiple. You can see one more thing here. The two values are created x and y. If you want means you can store it in the workspace also. Okay, so for example, if you double click this x means the values stored in x are stored. Why I'm telling means if you want to do any manipulation, or if you want to copy to some other sources like Excel or Word or to tabular column format, or if you want to plot the values from the editor itself, that is from the workspace editor itself, you want means plot and edit the plot also. You can do it very easily. No need to go for the plot commands. All types of plots, whether it is a bar or surf or mesh, all the things are available in the plot app. If you double click this one means it goes to the workspace editor. You can modify all these things. Okay, so function with multiple outputs. This is the function with multiple outputs. You are getting sending the single, and you are getting the multiple outputs. I am skipping this one. I think you hope you already aware about this one. You understand this is a self-explanatory. You can see the function of x size command. Okay, the function looks like it returns the two values, but it really only returns a single array with the two elements. It is the single array with the two elements, two rows, three columns. Don't take it as under two values. The size of x is two rows and three columns. This is the another built-in function. Okay, it's regarding the variable defined in the m file function only have meaning inside that program, that is local variables. If you are setting x equal to in the command window, it is not equal to 1 in that function. It is also in that area only. Okay, I am skipping this g function you are executed. Here you can see the output equal to g of x comma y. So you a equal to x into y means x, y, a and the output are the local variables. X, y and output are the local variables. When g is executed from the command window, the only variable created is determined in the command window, that is ans. Is the automatically the variable is created. This is another example. Accessing the M file code. The function provided with Matlab consists of two types. First in built-in, and code is not accessible to us, but if you want means you can view the code. Second type consists of the group of functions M file, just like the ones we have been writing. Use the type function to see the code in the M file. That is, the type is the function. If you want to see the sphere function stored in the M file. Okay, studying these functions may help to understand how to program better function yourself. For example, there are so many built-in functions are available. If you want to see what inside they return means, just you type the command, type sphere, type command, something like that. Okay, you can see user defined functions also. You can create the function in the you can see here type distance. Actually distance is the function created by us, so it gives the content of the distance. Okay, we wrote this function and saved it in the current directory, that's why it stores the function. Then user defined function, the add, another example. You can see this is self-explanatory only. Then converts the Celsius to Fahrenheit. Tc equal to 20, you are giving Tf equal to Fahrenheit of Tc. For this 20 Tc, what is the Fahrenheit means? You are writing the function for Fahrenheit as another function, in which you are returning the function. Okay, you can see here the Fahrenheit. that is the Fahrenheit, and the TF of Fahrenheit means we are going to be converts, this function converts the temperature Celsius to the Fahrenheit. So it calls this program and gives the TC as on the input here. Okay, and this is a simulation. T equal to 0 to 24, and TC is the sine value, TF is the Fahrenheit of TC. You can see here, just I'm zoom this one. T is the 0 to 24 in term by the step size of 0.1 I am giving. TC equal to sine t plus 1 into 20. TF I am calculating. Now I am plotting T versus TC, TC versus TF. Title is temperature simulation. X comma Y label temperature and Y label Fahrenheit. This is Celsius and this is Fahrenheit. You can see this one here. This is the function I created. I hope you understand this one. This is the function I created. I call this function from here for the various values of temperature. I am simulating and I am calculating the temperature in terms of on Celsius as well as on the Fahrenheit. Now I am plotting this in the plot. One more thing, we are having function of functions. Some function accept other function as an the input. I hope you understand this one. Function of functions. You can see f plot is the function. Okay, sin x is the another function. F plot requires the function is the first input field. Okay, so this is a sin x is the function. This is the function of function we are giving here. Okay. F plot ln, this function of this is function, and another function can also accept a function handle in the place of the function itself. Okay, in case of ln, sometimes if it is accepting means we can do it. Okay, so far we discussed about the built-in functions and user-defined functions with various inputs and outputs, and finally we discussed about the function of function, and we are having the S functions. Okay, we are not going to be discussed here. Just I am giving the intro regarding the S function. S function is used to add your own custom block to the Simulink model. For example, you wrote some optimization program in the Matlab code. Okay, but some part of the program it is very easy for you to do it in Simulink. But how to link this M code, or how to link the already existing C code, how to link the already existing C++ code. Sir, already I got some code from the net, sir. It is in C, sir, but partially some programs I done in Simulink. How to interface this one? That is interface. You can't do it by using the S functions. S functions can be used to add your own customized blocks to a Simulink. Actually, this is related to the Simulink, as the S function is the computer language description of the Simulink block written in either Matlab or C or C++, Fortran or Ada. The form of the S function is very general and it can accommodate continuous, discrete and discrete time systems. So, okay. So I will give the 2 or 3 examples how these commands are used for image processing, because yesterday some participants asked about how you can give some example for image processing. That's why yesterday I wrote these simple programs and I copied here. You can see the commands are same and syntax are same. Some inbuilt functions or toolboxes are exclusively related to image processing or video processing toolboxes. You can see here how to read and display an image. Img is the variable. Imread is the new thing to you. It is going to be read pixel by pixel and store it in terms of an matrix 250 by 255 by 255. So for example, img I am reading apple.jpg. Okay, now this is stored in img. dim is another function. I am doing the size of img. Okay, so it shows the size, and now I I am show is the thing, it is going to be show the image. I'm store it as under value here. It is the in terms of a matrix. Now I am know the size of the matrix. I am writing it the same image in another name. This is the another name and this is the format. You can see here. So in image processing toolbox, we are having the so many functions available. I am skipping this one. You can see here better. You can understand it is the binary images, means we are having the zeros and ones in terms of a matrix. If it is the intensity grayscale image, means we are having in between 0 to 1 values. It depends upon the intensity. Intensity, it is going to be stored here, intensity images, and you can see RGB images are available. We are having the M, N and P. Those things are multidimensional images are available. You can see here, read the image, size and write it. Reading the image, and in IMG we are having in terms of a matrix, the dimension shows the size of the matrix. It shows, it's similar to the plot command for the 2-dimension. It shows the matrix to in terms of a figure. For example, the apple is showing here. I am writing the same apple.doc to output.doc here. Now you can see, I think if you understand this one very clearly, how to build the matrix. You are building the matrix. Previously I told that I am going to get the data from the image. Now I am going to create the 255 by 255 matrix. You can see here, row column I am defining 256 by 256 and image equal to zeros of row and column. Now it is going to be create one matrix. We are having 255 by 255, which is having the all zeros. If it is the all zeros, means what happens now? If the image is the all zeros, means the image is like this. This is 0 1 0 comma 1, sorry, 0 0 0 comma 1 0 comma 2 up to 0 comma 256 and 1 comma 0 up to 1 comma 256. Finally this element is this pixel, not element, the pixel is 256 by 256. Now what I am doing is, image of, in the image, 100th row, 100th row to 105. This is 100th row and this is 105. All columns, instead of 0 I make it as an 05. You can see either it is not dark or too white or black. It is some gray color, since I am giving the 0.5. Next, for all rows from 0 to 105, this is 0 and this is 105. I have to make it as the 1. So all the things, it becomes white. If it is 0 means black, white means 1, and if it is 0.5 means somewhat gray color. Okay, so it is 1. Now if it is the figure, if I am show image, means it looks like this one. The matrix 256 by 256, I am showing it as the matrix, the image. Now you understand the images and matrix, the relation between the images and matrices. So if I am getting the value from the image, means IMG is like this only. It is the matrix only. Okay, so you can see it's like the salt and pepper. It is the row and column. The image equal to random is the random number which is going to be generated between the 0 and 1. The values are generated between the 0 and 1. How many rows and columns you are going to be generated? 256 by 256. So it is the matrix of 256 by 56. It has either 0 or 1, not black and white. It is in grayscale. Since I am giving the random value, it is going to be like this. Okay, it's like the salt and pepper noise. Okay, not noise, image. Okay, so these are all the some commands for the image display, the image conversions, gray to index image, image to binary, image to double precision. Likewise, we are having some commands are available, and the image operators are available for resize, segmentation, for finding the histogram, for finding the convolution, for the discrete cosine transform, the histogram equalization. For this, some built-in functions are available. Okay, so with this I finished the that is the image related MATLAB commands. Okay, Next, I'm coming to, since we are more concentrated on the control system toolbox, it supports the continuous time models and discrete time models of the following types. It is the transfer function and zero pole gain and state space. These are all the following things it supports by the control system toolbox. Okay, so I hope you already know about what is the transfer function in terms of the S. In Matlab, by storing the coefficients of the numerator in Matlab, for example, in physically, how you are visualize this one, g of s equal to s square plus s plus 2 divided by s plus 1. Okay, so what happens here? H of s equal to b of s by a of x. S of x is the constant and power, constant power like this. So you are going to be store these coefficients in the num variable and then variable. Don't think that this is not a thing you must give for the numerator and denominator. Just for easy understandability only, I am giving it as on the num and then. So bm and b2 and constants. It starts from, if you are giving the three variables in num means the right hand side, right one is the constant, next one is the s1 and next one is the s square. In this way only the Matlab understands. Now you can see here, use tf function. Tf is the function to form the transfer function in the Matlab. Okay, h of s is the 2s plus 1 divided by s square plus 3s plus 1 is the given thing available. So what are the coefficients we are having? 2, 1 in num. In then what is the s 1, 3, 2? 1, 3, 2. Now I am making the transfer function h equal to tf comma num comma then. So what happens now? If you are the window, command window, you are getting like this: 2s plus 1 divided by constant s dot s square. Now s square 3s 2. For example, here 201. If I am giving 201, what happens now? 2s square plus 1. 2s square plus 1. Okay. Then if you want means you can include the delay to the continuous time systems. For that, the transfer function num then input delay comma 2. You can see this e power minus 2s into 2s plus 1 divided by s square plus 3s plus 2. Okay. So to find the zeros pole, sometimes you need for finding the stability means you need to find the zeros of poles and gain of the transfer functions. So from the vector num and then, which contains the coefficient of the numerator and the polynomial. So the transfer function to zp, transfer function to zp of num and then. Okay, so it gives the zpk, 0, poles and gain. 0 is this one, poles are this one, gain is 5 for this transfer function. Okay, so zpk command, you can use the zpk command to create the transfer function to the following form. Now then it's a reverse for this one. From the it's tf to zp, this is zp to where it is transfer function. Okay, so the command is zpk, that's all. Okay, so we like if you compare this one by tf means num and then only we are giving. If you are giving the poles and zeros and gain, you can give this one zpk 0 pole gain. Okay, so it is, the output is going to be looks like this one. Okay, then continuous time systems, we are having the state space model for the dynamic system. X dot equal to x plus bu, y equal to cx plus du. Okay, the matrices A is the state matrix, B is the input matrix, C is the output matrix, D is the direct transition matrix. Small x, u, where is u? This one is u and y are the state vector, input vector and the output vectors. Okay, so now you can see, you can use like tf, like zpk. Now I am going to use the ss. The ss function creates the state space model. So you are having the x, a, b, c, d. A, B, C, D you are giving. System is the variable in which the state space model is going to be stored. S is equal to A, B, C. Okay, so the Matlab output is going to be like this. Okay, so these are all the conversion between the different models. You can see, if you want to convert from the transfer function to ZPK, so TF to ZPK, TF to state space, ZPK to transfer function, ZPK to state space to transfer function, state space to ZPK. Okay, these are all the two functions from which form to another form. So mostly in control system we come across these conversions. We need these conversions. Okay. So I'm skipping this one. We are having the discrete time models, and I'm not going to skip it. The previously in terms of the continuous, we are having in terms of an yes. If you are going to study the discrete control system, so all the transfer functions are in terms of an z. So we are going to be use the TF functions to create the transfer function of the following form. If you want to do the h of z equal to 2z plus 1, z square plus 3z plus 2. If it is the discrete time transfer function, means surely you need the sampling time. You must be indicated in the input itself. It is num then ts equal to 0.5. So if you are giving the ts in the tf itself, if your MATLAB understands this, it as on the discrete time function. So MATLAB output is not yes in terms of 1. Previously, if I am not giving the ts, means it is going to be taken as on the 2s plus 1 divided by z square plus 3s plus 1. But it is going to be the discrete time transfer functions. Okay. So you can see another one. If you want, means you can give the ZPK model with the discrete time transfer function also. It is the to create the transfer function in the following form. Okay. So this is the discrete time state space model. Previously, I am giving the continuous time state space model. Here it is going to be in the discrete time state space model. So I am giving the x, a, b, c, and giving the sampling time also for point 1. So this is the way of defining the discrete time transfer function. Okay. So next one, the partial fraction expansion. Most of you come across the how to find the partial fraction expansion of f of s. This is 2s cube plus 9s plus 1 divided by x cube plus s square plus 4s plus 4. So num then I am giving the command is residue of num comma den. You are giving a residue of num comma den. Okay. So it is the RPK. You are getting the output like this. Back to the polynomial form means num den equal to residue of RPK, means you are getting num and den, and you can give the TF of n numerator and denominator, means it's not num and den, NUD. Okay. So you are getting in terms of a transfer function itself. Okay. So RPK means residue of B comma A. So the residue of B comma A. Okay. The numerator and the denominator finds the residues, poles and direct terms of the partial fraction expansion of the ratio of the two polynomials b of s by a of s. B of s to b of s by a of s, it is going to be give the partial fraction expansion. Okay, the residues are stored in R, poles are stored in P, and gain is stored in K. Okay, you can see here. This is the ratio of the polynomial. I'm giving B and K. I'm getting the residues on polynomial, and you are getting R1 of n, R2 of n. This is the poles. You are going to be get the partial fraction expansion. Finally, if you are having the gain, means it is added at the end. So how we are going to be combining the models? The model can be thought as in the block. We are having the model, it is thought as in the block with the inputs and the outputs and containing the transfer function or state space model inside it. A symbol for the mathematical operations on the input block to the block that produces the output. Okay, just this is the elements of the block diagram. You can see here. This is one transfer function and this is one transfer function. If I want to combine this transfer function, I have to make it as on the single transfer function, means the command is series. This is parallel. This is unity, sorry, not unity. This is the feedback. So the names are very easy to remember. The system is the new transfer function, which is the combination of G1 of S and G2 of S, which is in series, and this is in parallel, and this is in feedback. So how we are going to be, if you are having the another G3 of S, means no issues. You can give the series of G1, G2, G3. Here we are having three parallel spins, you can give it. Okay. So and you can see here num C loop is the unity feedback. This we are having in feedback, we are having some transfer function is available. You are having the unity feedback. If you are having the unity feedback, means you have to use the, instead of feedback, you can directly use the C loop numerator comma denominator to reduce the series system to a single transfer function. Series of num num g den g, that is this one num g den g. then G, and parallel it is going to be it is the num h then h. To reduce the parallel systems, you are having the parallel num g. Actually, this is the first transfer function. This is the second transfer function. We are going to be, this is like this. This is the transfer function of this. This is the transfer function of this. Series means we are having that like this. So the num and then g, this is the transfer function. Num h and then h is for the transfer function. This is the series. Okay, I hope you understand this one. How to make it as in the combining the models by using the series command, parallel command, feedback, C loop, etc. If it is a unity means you have to do this one. Then basic operations for the transfer function. Okay, so don't, sir, why are you repeating this one? Means already we discussed about some basic operation. Means here I am talking about the transfer function, continuous or discrete transfer function. I have to make it as a single systems. Okay, so single system G1 plus G2 is the addition, multiplication. If you want to do the inversion means you can do it. Okay, then very important one. How if you want to do some simulation for a system, first order system. Most of you in the first years or second year or third years, you see the response of the first order system, second order system, third order system. They are having their giving the input as in the step input and see the outputs. How you are going to be find the response of a system for the particular input. The particular input means maybe a step input or ramp or exponential decreasing or exponentially decreasing, whatever it may be, impulse. You can give anything. You are having assume that you are having the system. You are having the system means you are having the numerator and denominator of the transfer function num and then. And num equal to values, then equal to values. Now what happens? You are having step. If you want to plot the step response means you can see the command step of num comma then, or otherwise you can do like this also. G equal to tf of num comma num divide by num comma then. Now your transfer function is G. Step of G. Step of G. Like this also you can give. So likewise you have give the impulse response. For the response to the arbitrary input, use the command lsim. Okay, sometimes you need this one. So you create a vector t which contains the time values in seconds. So what you are going to do? T colon 50 colon 1000. Define the input vector. That is the input vector x function. For example, it is a ramp function. It is linearly increasing. For example, by using the inbuilt functions like step, impulse, LCM also you can give, or otherwise you can create your own vector which contains the time values in terms of a second that may be given as the input also. To compute the frequency response of the h of your transfer functions, as usual, you can store the numerator and denominator of the transfer function in the vectors num and then. Define the vectors. Now it is computed. It may be the frequency of num then w, or you are having the BODE is also available. By using that also you can plot it. Okay, the transient response refers to the process generated in going from the initial state to the final state. Most of you heard about the transient response analysis. You heard about the term. What is the transient response? The process generated in going from initial state to the final state. The transient response are used to investigate the time domain characteristic of the dynamic systems. Okay, so if you want to analyze the time domain characteristics, what is the peak value, where it settles, where it whether it is a sluggish process or we are having the fast process. The time domain analysis, if you want to find the offset, like this means you are having the transient response analysis to investigate the time domains. Common responses are usually step response, or it is the impulse response, or a ramp response you are giving. Now you can give the you are going to find the step response for this transfer function. This is the num and this is the then, and t I am giving 0 to 7 in terms of 0.1 step num comma den comma t. So I am giving the grids also. Sometimes the grids are used to calculate the peak overshoots or offsets, something else like that. That's why I'm purposely adding the grid. I'm giving the title as on the unit step response of H of S. This is the title. Now you can see this is the response. The x-axis is the time, y-axis is the amplitude, and this is the unit step response I am given here. The time is from 0 to 7. You can see here from 0 to 7 I am giving the step response. The step is going to be like this. This is the input. Now your system is going to be respond like this for this step input. What I am saying is clear or not? And alternative way of the unit step responses, you can see here. I already told this one. You are having the h equal to transfer function of num comma 10. This is the step h, and if the step input is 10 times, if you want to increase means you can give like this also. And you are having the ramp function, transient report Matlab code for the ramp functions. You are having 0 to 1 and plot, and you are having the ramp function. I am creating this one, a transient analysis of the ramp function and frequency analysis. Okay, so the board diagram representation of the frequency response, it is usually the Bode plot having the two plots. One is the log magnitude plot of the transfer function, another is the phase angle plot in terms of a degree of the transfer functions. You are having num 10 and board of num comma 10. So the title I am giving it as on the board of Bode plot of h of s. For this transfer function I am finding the frequency response, and we are having this is the Bode plot and this is the phase plot. Okay, so you can see the stability analysis in most of the process control applications in the chemical engineering. Check whether the system is stability or not. Okay, for this usually you have to use the Nyquist plot for the stability analysis based on the frequency response. If you want to find the stability of the response based on the frequency response means you have to perform the Nyquist plot, that is draw the Nyquist plot. So from this you have to determine whether the system is stable. Also you find the degree of the stability of the systems. Okay, so you can see this is the num and this is the den. Like Bode, you are having the Nyquist is available. There is one function called Nyquist is available. In the Nyquist the inputs are num and den, and you have to add grids. Now this is the Nyquist plot of this transfer function. This is the another frequency response. Like the frequency response, this is the another frequency response. Okay, so now I am passing to the Simulink, because so far I am giving the more introduction to the Matlab codings only. So it's very easy. Those who are afraid of codes, sir, it's very difficult to write the codes, sir. If I'm writing the codes means it's impossible to debug. If I'm having the errors like that means it is the very easy one. It is the block oriented approach. Just place and drag. Okay, we are having the blocks are available. Just you are going to be drag it and you have to place it in the file and you have to connect. That is softwaring you are going to be do, and you have to run it. Okay, so this is the thing you are going. Simulink is the add-on to the Matlab. Okay, so this is the add-on. You need to have the Matlab in order to use the Simulink. So in separately you can't use the Simulink. Used for simulation of the any dynamic systems. In Simulink we can create the graphical block diagram. Okay, you can easy to understand, very easy to understand and do it very easy. From the Matlab coding also you can send the data to Simulink. From the Simulink also you can send the data to Matlab. From the Simulink you can run the M codes. From the M code scripts you can run the MDL block, that is a Simulink block. Okay, so based on the differential equation it is going to be. So it is one of the latest version. In the topmost you are having the Simulink library is available. Just you click this one means you are getting this one. Button means you are, or just you can type here Simulink in the command prompt, you are getting this one. So you are having the libraries in the Matlab. What I told, this is the built-in functions, commands like that I am told. Here we are having the libraries. All the libraries are that is the graphical block diagrams. It is in terms of blocks. Okay, you can see in Simulink commonly used block, continuous, discrete, and you are having sync sources, you are having the control system toolbox, fuzzy logic toolbox, HDL coder, this is for VLSI, numerical network toolbox, like that. There are so many things are available. Okay, so according to your wish, what you are going to be using depends upon that. You are going to be add on the toolbox to the libraries. Okay, in common toolbox we are having these blocks are available. Now I have to start creating the Simulink model here with the blocks from the Simulink library. Just drag from here, and from the file you have to put new and drop it and software it. You can see here. Now I am start creating the Simulink model. After go to the file and new, you are getting like this. Initially the title is untitled. The default is untitled.mdl. Here the extension for the Simulink is mdl, whereas in the commands you are having the .m is available. Just from the libraries, just you click it, drag it, and put it in the window. Okay, now I am from the sync. I am take the sine wave and the from the source. I am take the source means this one. If you double click this means we are having the n number of sources available. If you double click the things means we are having the plenty of sources is available. Just from this I am click it and drag it here, I am getting this one. If you double click the sine wave, we are having the input parameters are available. So we are having the amplitude, frequencies, the samples, those things are available. Okay, so if you want to change some parameter means you double click the block. Okay, this is called the Simulink one example. After this you save it, and if you run this one means you are getting the output. You are getting the output like this. Okay, you can see here Simulink you are having the sine wave, and this is the one scope, and one scope I have putting the another block called transport delay. Now I am integrator is the another thing available in the commonly used blocks. Okay, you are having sine wave one and another sine wave with the delay. You can see this delay, this transportation delay. How much delay you can give here? If you double click this one means you can give the parameter of the delay parameter, and the same sine wave is integrated here. You can see here this is integrated. This is the 1 by s form of this one. Okay, so this is another example for the Simulink. Okay, I hope you understand this one. Now most of you in the chemical industries or in process controls, we are going to be model the some equations. You can see dx by dt, that is x dot equal to a by x, where a equal to minus 1 by t. Okay, so we are going to be start drawing the simple block diagram for this model. Just you can see this is the integrator. X dot you are giving it as the input to the integrator means x. The x and a is multiplied, which gives the x dot. I hope you understand this one. T is the time constant. Use the following parameters to simulate this one. T equal to 5. The initial value of the x is 1. The small t ranges from 0 to 25. Okay, so I take the integrator instead of this, and I want to see the response, so I have to put the scope. From this I have to put one gain block. If you want to multiply the any signal means how to put the multiplier gain block. Just 0.2 times it is multiplied. Since I take it as an t a equal to 1 by t minus 1 by t, here I am giving it is the gain. So this is the response for this one. Okay, hope you understand this one and how to make the models. Then we are having this Simulink. Okay, the same thing. What I told here, the initial value is 1. So how we are going to give the initial value? You double click here, integrator. You can give the 1. So how long you are going to be run this model 0 to 25? So you can give here 0 to 25. This is the scope. So if you double click, I already told that a equal to minus 1 by t. The double click on the different blocks to enter the values. Okay, So this is the 0.25. If you want to make it as on the 0.5 means you have to make it as. Okay. Okay, then this is a Simulink model, how to give the parameters. Another important thing is how you are going to, as I told in the beginning itself, what means you can combine the Matlab and Simulink. That is the data driven modeling. The name of this is the data driven modeling. You may use the Simulink together with Matlab in order to specify the data and parameters to your Simulink model. From the M file, you can send the parameters to the Simulink. Okay, you may specify the commands in the command Matlab command window or in the M file. This is called data-driven modeling. The data is driven from the M file for running this Simulink file. Okay, so instead of using the values directly, you use the variables. Directly means what? Here I am giving the direct value 0.2. Here I am giving the direct value as 1. Instead of this, I have to give the variables. Why I am giving the variables? For the flexibility. We can easily change the simulation parameters without touching the Simulink model. So each and every time if you want means you can go on double click initial value. I am starting from the 5 sir, 10 sir, 20. So I am changing the value of the t. It's not 5, 10 I have to find the response, 20 I have to find the response, means better for the flexibility you have to make this as and the variables instead of the constants, that we have to see by means of a data driven models. You can see here, so in the 1 by s, instead of I am showing, so instead of 1, what I am giving, x0 is the one variable, x0 is the one variable I am giving. Instead of the value 0.2, what I am giving here, a is the value. Now what I am going to do, this is already done in the MDL. Okay, so you can see here, now I am going to the M file, scripts. Okay, now from the scripts, I am going to run this Simulink simulation. So writing the file, clear screen, clear the variables, clear the screen, x equal to 1, initial value t equal to 5, time constant a I am calculating, t equal to 25, t stop, that is t, sorry, t stop is 25, t underscore s equal to t stop divided by 1000, then options equal to, we are having so many solvers are available. Okay, so method to solve is ODI 45, ODI 23, ODI 113, ODI 15 with fixed step discrete, like that. So many ODI solver, ordinary differential equation solvers are available. Now I am going to be using the command called simset. What I am going to do, simset means it is going to be creates the Simulink of this solver ODI, and fixed step it is taken from TS, step size it is taken from here. Now start simulation. Now it is over. Sim is the command. Sim is the command for simulating the Simulink file from the Matlab. What is the name of the your created Simulink? Is the Simulink underscore exe2. This is name. Simulink underscore exe is the thing I am given here. T stop this one, options are this one. So now it is actually this is the output of this one. Here you can see I didn't give the plot commands. So this is the plot of the scope in the Simulink. So there is another example. You are having the AX plus BU. Just I am skipping this one. X dot equal to AX plus BU. We are having the B and having a step input, the 1 by integrator, and we are having which is multiplied with minus K and it is added with B and U. This is BU and this is AX, and you are getting X dot. Okay, so okay, I think is it clear? You are getting this one. The same thing, if you want means you can simulate from the Matlab scripts also. The data are driven from the, for the Simulink, the data are driven from the scripts. Okay, so we can see some more examples by using the Simulink. Just I am rushing for this one. You can see there are some constants are available. The constants are the blocks which is available in the Simulink. Just I am adding a plus b minus c. This is constant. This is not matrices. Don't think it is on the matrix. It's a single constant. A, if you want means you can increase it. You can double click this subtractor. This is a one block. This is another block. This is another block in sync, and this is the another block in commonly used one. This is the another block in sinks, and this is another block in sources. If you want to increase means this is the 3. The parameter is the 3 here. If you want means you go ahead with 5, 6, 7, 8, 9, 10 like that also. Now the display instead of plot or scope I am giving it as the display. So you can a plus b minus c, a plus b plus c. So this is the add and subtract, and you can see here gain block. This is the sine wave and one gain block, and you can see the slider gain. There is one slider gain is available. This is the mux block. There is one mux block. Just I'm combining these two signals and make it the scope. You can view it in the scope. The slider, this is the constant gain. The slider block performs a scalar gain that you can modify the running during the simulation itself, modifying the gain using the slider parameters. Okay, so you can see the output here. So this is the first one which is having the 3, and is the another scope. This is the output of the scope. Okay, so now you can see here there is one bias block is available. So the bias block means input plus bias, input plus bias. Okay, so the what is the input? Sine wave. The sine wave, the how you are going to, first you take the sine wave block and take the bias block and take the mux block and take the scope block and connect it. If I am giving the sine wave directly to the scope means you are getting the sine wave like this. Then I am adding with 2 the value minus 2. Sorry, yeah, 2. Okay, y equal to this output is the y, the u is this one, bias is this one. These two things are added and give the output. This is the significance of the bias. Okay, so this is for the complex number conversions we are having the constant 2 plus 2y. The complex to magnitude angle block outputs the magnitude and phase angle of the input signal. This is the input signal and this is the output. Again I am converting the magnitude angle block to the complex. You are getting the same thing. You can see here you are getting the same thing. Similarly you are having the real imaginary to the complex. You are having the complex to real image. Okay, so I am doing the vice versa here. Okay. One more thing, the math function block is the another function it is available. Performs the following common mathematical operations. So for example, this is the constant, this is the block of the name, this is the display. Okay, so these are all the possible operations you can do it here. You can see. Then you are having the relational operators are available. A and B are the matrices. These are all the matrices. A and B is available. Determinant A and determinant of B. We are going to be do the conditional operators. Okay. So what happens? The relational operator block. There is one relational operator block is available, in which the operations, these are the possible operations. If you double click this relational operator, it is asking the option whether it is whether you want to do the equal to or less than or greater than or equal to, something like that you are going to do. So this is the relational operator. We are going to do this. We are comparing and get the output. Okay. So so at the Matlab command prompt we are getting the A and B as follows. Okay. Ports and subsystems are available. Creating the subsystem. Okay, so what is the subsystem? Okay, systems, you know, these are all the so many blocks are available. Okay, so actually group blocks in the functional subsystems create the model hierarchy. That is, for example, if you are creating a very large model for some bioreactors by using the Simulink, what happens? The model increases in size and complexity. It's very difficult to debug, or if you want to change something or to visualize, it's very difficult. If the model increases, the parameters and the blocks increases means it is very difficult for the model increases. If you want to simplify it by grouping the blocks into subsystems. The subsystem is nothing but a set of blocks that you group into a single subsystem block, okay, using the sub block. For example, just you can select this, since it is not a simulink, just I'm in the PPT I'm doing, you right click and it, not here in Matlab I'm telling, it right click and it asks for subsystem. If it is the subsystems means what I mean, it comes under the single group. Here instead of 4 displays, I make it as in the subsystem. Actually it may be like this, 3 displays, just I am grouping it and make it as in the subsystem. Then what is the enabled subsystem? Okay, the enabled subsystem means you are having the sine wave and you have the output. If the constant value is, if the enabled input, if the value is greater than 0, okay, for example, the some outputs are coming from the previous blocks. That block is going to output is 0. Whenever it is greater than 0, if you are going to be enable the some process means you can use the enabled subsystem. After that only this subsystem is enabled, in which if you double click this one means you are having the group of some subsystem systems of blocks are available. Okay, that is called enabled subsystem. This is called the manual switch and multiple switches available. This is the constant 1 and constant 2, and this is the display. Just if you are after running, if you click this one means it is toggle between these two things. Either you can get the constant 1 or constant 2, or you can give some subsystem here, or if you can draw some blocks like this, you can do it. And this is the multiport one. This is the control input. It is going to be desired the which input you have to route it to the scope. This is called multiport. And okay, and one more thing is available. Switch block is available. The switch block allows the first input and third input depending upon the second control input. This is the control input U2. If U2 is greater than the threshold value, what happens? The first and the data input. Second is called the control input. You can see. You can see if you double click the this switch means you are getting this one criteria for passing the first input. Okay, if U2 is greater than the threshold, I am giving the threshold value here 1 2 3 4 whatever it may be. If U2 is greater than threshold or less than threshold or equal to threshold, you are getting this one. So you can give the step input. Initially the step input is 0. Okay, so that's why it is getting the third one. Condition is not satisfied. U2 is greater than threshold. Since it is a less than threshold, it is giving the sine wave. So after that, what happens? The step wave I am giving for 0 to 40, I am giving the 0. After 40, I am going to make it as on 3. So what happens? So now the condition is this is satisfied. Now instead of sine wave, I am giving the pulses. So how to solve the differential equations here? So you can see here, given the differential equation dy by dx equal to x and dx by dt is minus y. Okay, so setting x1 equal to x and x2 equal to y. So instead of y, I am putting x1 dx2 equal to y. So it is the Matlab script. You are getting the values of both x and y. So here I am using the ODI 4-5 method for this one. The solving the differential equation using the Simulink. I think this is already told. Participants, just within 10 to 15 minutes I will finish, then you can ask the questions, then it's easy for me to answer your questions. Just within 10 to 15 minutes I will wind up the session. Okay, so this is for the solving the differential equations by using the Simulink. Okay, this is the differential equation to state space functions. You are having A, B, C, D. you are having state space block is available. You are going to be giving what is, if you double click this one means you are asking for A, B, C, D is available. Then initial condition you can give, and you can give the step input. Instead of transfer functions, you can give the step also. Okay. Similarly, you are having the transfer function block is also available, in which the inputs are numerator and denominator, and you can give the constants of the polynomial you can give. Then I'm skipping this one, and this is, you can see here, this is very useful for you. This is some input and this is some system. Don't bother about the subsystems. Something is available. This is one output is display. Another output is scope. You can view it. Another output is I am storing it in file. How to store the output in the file? Because whenever if you are doing the some plot commands, it is not if you want to paste, or if you are preparing some papers, journals, means it is not possible to get the plot from the Simlink scope itself. For that, better what you can do means, if you want means, you can store it in some variables or in files. Then you can make use of the plot commands. Then only it is very nice presentation in your journal papers. You can see here the output is going to be the stored in the file electrical.mat. Okay, so after running this one from the Matlab commands, you can load in the file electric.mat. In the Simulink I am storing, now I am from the Matlab script. Okay, what I am doing, just if you are double clicking this to file, if you are double clicking the to file, means what happens, it asks the file name, okay, variable name, okay, decimation, just you can giving electric.mat, then you can run this one, then load electric.mat. Now the file is loaded and plotted. Okay, now you can get the plot. Those plots you can copy it and paste it in the Word or PowerPoint or in Excel, whatever it may be. Then it is for the visualization, it's very nice if you are get it from the Matlab means instead of scopes. Okay, so another one, to workspace. Okay, what is the meaning of the workspace means, I am storing it in variables, some variable. You can see the outputs are stored in I is considered as the one matrix in which so variables are stored. Okay, so you can see here, if you double click this one, you can give the variable name. Okay, so then you can save the format also, whether what format you can store. Better you can store it in array. So what is I of 0, I of 1, I of 2, I of 3, I of 4, I of 5, something like this. So you can see this one from file to Simulink. Okay, so this one is, actually you can see the difference. This is to file. This is for storing the output in this file. Now assume that in some files the data are available. Okay, you can see the T1 I'm storing this one. T1 equal to randomly I'm giving 0 to 20. Y1 is this value. Y2 is this value. I'm storing it in JJ. Save the signal JJ. Okay, then now it is stored in the file called JJ. This I done in Matlab scripts. If you want to get the values from the Matlab scripts, I want to display it or I want to use it in the Simulink means, just you can use from file block. Previously I used to file block. This is the from file block to scope. Okay, so it is going to be displaying these values like this. Then use of the function block. Okay, so there is one function block is available. This is the constant. If you double click the means, you can give the expressions whatever it may be. Okay, so the phi into exponential of minus u plus 20 plus pi. Okay, so this is the function, whatever it may be you can give. Here this is the input is u 0.1, that is multiplied, that you can see, I will zoom it. the input is u, that is find e power minus 5 for example into 5 plus 20 plus 5. Okay, so this is the Matlab functions. I'm skipping this one. The access the Simulink file via my M file. This also I already told that. So the name of the file is RLC. Don't bother about this one. Some files is available, RLC circuit.mdl. You can simulate it from, these are all the values. 3 times I'm going to be simulate RLC circuit.ml by using the command called sim. You are getting this one for I equal to 1 or LC or the variables. 3 times I am running, so you can get the plot, 3 different plots. So this also I had already told that regarding the differential equations, ODE solvers. I'm skipping this one. Then I'm coming to the another topic called interpolation. Okay, what is the interpolation? Interpolation is used to estimate the data points between two known points. I want to interpolate. You have to find the unknown data. The most common interpolation technique is the linear interpolation. Okay, so you can see these are all the xy data which is available for x0, y is 15, 1, 10, 2, 9 like this. My aim is we want to find the interpolated value of x equal to 3.5. Since the 3.5 is not available here, I want to interpolate the value. For this, I have to do the m code. M, that is x equal to 0.5, y equal to 15. Sorry, 0 to 5, not 0.5. Sorry, 0 to 5. Since it is having 0, 1, 2, 3, 4, 5, y. Now I am plotting the value. Find the interpolated value for x equal to 3 up to this. Just I am plotting. It's like this. For 0, 15, for 1 it is the value, for 2 this is the value, and for 3 this is the value, and 4 this is the value, like this. Like this. From the plot, just you can guess. I asked you to find what is the 3.5 value. Sometimes for the 5 values only you are having the data, for the 5x inputs only you are having the output. So if you want to interpret the value, just you have the guess, means from the figure you are giving the guess. So by using the paper scale, for 3.5 you are getting the approximately 4 or something. This is the thing. In the coding you can see new x equal to 3.5. I am using the command intrp1 x y new x, for which value have to interpolate. And one extrapolation is also available. Here I am talking about the interpolation only. Okay, you can see here you are getting the value 3.5. Sorry, I will show it. The Matlab gives the answer 4 actually. The guess also from the figure also you are getting it as the 4. You can see here new underscore y. Okay, this is called the interpolation. Now curve fitting. Okay, so in the previous slides we saw about the interpolated points, that is we found the values between the measured points using the interpolation technique. Okay, if it is actually it is more convenient to model the data from the given data. If you are model using the mathematical function means, then you can calculate any data based on the model. You can get any data. That is, model means it is in terms of a first order polynomial or second order polynomial. Okay, so it is like this. So this is the mathematical data, input data. From this I am going to be model it y equal to f of x. Okay, you can see you are having the functions polyfit and polyval is available. Okay, Matlab has the built-in curve fitting functions that allow us to create the empiric data model from the given data. Okay, it is important to have in mind that these models are good only in region we have the collected data. So what I'm trying to tell is the range or region is within the collected data, input data, means it is give the good outputs. That is, you can see here, I'll give the example. This is the polynomial we are going to be developed from the given input and the output data. Okay, the p1, p2, p3 are the coefficients. uh, from the given data, the model needed is in the form is y equal to ax plus b. This is my guess only, y equal to ax plus b. Okay, you can see here x values, y values, and polyfit. What is the one here? I am going to take the first order polynomial. If you want, means go for the model, you can go ahead with second order, third order, fourth order polynomials. So a equal to p of 1 and b equal to p of 2. So y model equal to, where is it? A equal to y equal to ax plus b is the model. So this is the a and this is a and this is b. So the plot x, y and x versus y model. You can see this is the actual data. This line is the model, the first order model. Okay, so you can see here, we will investigate the models. If I am getting the models by using second order, third order, fourth order and fifth order, you can see I am getting the bearing here. You can see previously I am putting 1 here. Here I am getting 2, 3, 4, 5. Okay, so for 2 you are getting the polynomial this one, 3, 4, 5. So this is second order polynomial, third order polynomial, fourth order polynomial, fifth order polynomial. So you are getting the following models. Okay, now you can see the that is plots for the second order, third order, fourth order, fifth order polynomial. What is the conclusion you are getting? If you go for the higher order models, it matches the data better. You can see the first order polynomial, it is not matching. Approximately it is going to be matches with the actual data, but you can see the model with the order of 5, it exactly matches. Okay, then I will give the very small intro to the optimization. Okay, so what is the optimization? Is based on finding the some minimum of a given criterion functions. Okay, so in Matlab we are having the f min b and d, and f min search or the functions are used for optimization. Okay, you can see here x equal to f min b and d function. I will explain this one, x1 x2. It is attempts to or find a local minimizer x of the function fun in interval x1 and x2. Okay, you can see here x equal to f min of, this is the function, this is the function, and x1 and x2 are the intervals between 3 and 4. It is the minimum value. Same thing from starts from x0 and attempts to find the local minimizer x of the function. Okay, you can see here it is a given function. It ranges from -5 to +5. Y equal to my function of x. I am writing the function here. Function here. It is a separate one. Function f equal to my function x of this polynomial. Okay. Here you can see the plot of x comma f. Okay, f equal to my function of x, plot of x comma fun, f x min equal to, now this is the plotting between x for various values of x. I hope you understand this one. 5, 4, -3, -2. I am generated this one by using this. These values are substituted here. We are finding the value of f of x. This is plotted in the y-axis. Now I am going to find the minimal part. For this, I am going to be using the f min b and d. I am going to add m function. F min b and d, 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 m function. It is the function which is available here, which ranges from -5 to +5. Now from the figure you can see by visualization which one is the minimum, -5. The Matlab fmin bnd also giving the -1. Okay, I skip this one because the time is running out. I am skipping that. I already told the curve fitting also. There's some more examples for curve fitting. You can see, just I will show, if you want means you can see it afterwards. I will send the PPT link to you. Numerical differentiation, y of x equal to x square. You know that dy by dx equal to 2x. Okay, by using this one, this is called the exact solution. 2x is the exact solution. I am plot here. Okay, so the numerical solution is dy by dx is the variable, diff of x and diff of y. This is the function I am using. I am comparing this with exact and num. It's almost matches. Okay, this is the, you can see, this is the exact solution. This is the numerical solution. Likewise, okay, actually, if you are increasing the number of data points, what happens means the actual data and numerical solution data are matching. Okay, instead of -2 to +2, instead of -2 to +2, in terms of one I am giving here, in terms of 1.1 I am giving, means you can see how it matches. So if it is still, if it is the 0.01 means, then it is going to be exactly matches. It's another one example for the numerical integration. There is one the command called trapezoidal method. I have to calculate by using the trapezoidal method. Okay, I'm skipping this. We already discussed. I hope we already discussed this one. Frequency response, and you can, one more thing you can see here. If you want to do controllers, design the controllers for the transfer function, general transfer function. You are having the model. If you want to find the controller transfer function means, sorry, PD controller means, well known is the PID controller. Apart from that, there are so many controllers or conventional controllers are available. Well known is the PID controllers. It is the form of proportional plus integral plus derivative. For this, we are having in Simulink, we are having the ready-made block is available. If you double click this one means, you are, it is asking the value of proportional value, integral value, that is Kp by Ti, and derivative value. If you are making this derivative value 0 means it is the PI controller, not PID. Okay, so how you are actually by trial and error here, also you can put the Kp and Ki. Some, up to some extent it's working. Otherwise, some tuning methods are available in Matlab also. In that is in control system. I hope you studied about the Ziegler-Nichols tuning, coherent tunings, like that. So by using the tuning methods, you can find the Kp and the integral values and put it here. And you have, you can see here, this is the step input and this is the closed loop. Okay, this is the PID and this is given to the some disturbance given here, or otherwise you can directly give the controller output to the plant. Output of the plant is fed back to the input. Here the error is generated. This is the set point. This is the process variable. This is set point. This is PV, process variable. This is the error. Error is given as the input to the PID controller. PID controller output is added with the disturbance. Actually, why I am adding the disturbance here means I have to examine, even though if you are having some disturbances, how the controller is going to be control the plant. For this one I am putting. And now you can see the outputs. This is the one output getting from here, and another output is taken from the controller output. Step input, and you can see this is the process output. This one, this is the process output. Okay, initially for the step input you are getting the process output like this. Actually here what I'm done here is after 50 seconds I'm giving the disturbance. Here if you double click the step input means you can give like this. So after 50 I am giving the disturbance of 0.5 at the amplitude of 0.5. So what happens here? So it is reflected in the process output. So controller is taking action to bring back the output to the unity step input. So to analyze this controller whether it is working, instead of we are instead of we are having the various disturbances, whether it is the upward disturbance or negative disturbances, whether the controller is taken action or not. Okay, taken action or not. So for that only I am giving the disturbance here. Okay, so this is the example for the PD controller for some third order process. So this is the plant, this is the transfer function in terms of a numerator by denominator we are giving. This is the PID controller, one summer block you needed. This is a step input, this is the set point we are giving either in terms of a temperature, concentration or level or flow, whatever it may be. And you are having the feedback. This is the feedback means it is going to be measure the present the concentration or level that is compared with the set point, and it is going to be giving the errors. One more thing, you are having the CSTR reactors. Okay, so for the CSTR reactor you can see the parameters of the CSTR, or you can see here the H of T is the liquid level of the CSTR. The H of T is the liquid level of the CSTR. CB1 and CB2 are the concentration of the two liquids, the liquid 1 and liquid 2. W1 and W2 is the flow rate. W1 and W2 is the flow rate. The W1 is the flow rate of the concentrated feed CB1 and W2 is the flow rate of the second liquid, and input concentrations are now set to 24 and 20 something like 0.1 input concentration for CB1. I have to set it for this one concentration. I am going to be set it, I will explain with the 24 point something 0, and CB2 concentration I had set it for 0.1, and constant associated with this K1 and K2s are 1. For simplicity I have to take it as a 1. This is the dynamic model of the CSTR system. Okay, so you can see here DH by with respect to height and with respect to constant output concentration. I am writing the two equations. So now what I am going to do is I have to realize this equation in Simulink. This is the open loop only. Okay, so CB2 is 0.2 I am giving, and one more thing, CB1 is 24.1, and these are all the constants I am giving. Just I am realizing, I am make this dynamic model to the Simulink model by using the square, product, integral, and so many things I am to use it, and this is the response for this one. This is the flow rate of the concentrate feed, input output of the CSTR. Okay, so you can see this is the plant output. It starts from 24.9. This is the product concentration. This is the height. It starts from 30 and settles this one. So this is the open loop model. For the same thing, I am designing the PD controller. I am designing the PD controller for the CSTR process. Okay, you can see here the set point changes from 20.8 to 22. You can see here 20.8 to 22. This is the set point I am giving here, and this is the PD block in which I am giving the proportional and integral values of 2 and 0.9, and I am giving the controller output. I didn't give the disturbances here. This is for weaving the step, and this is for weaving the plant output, and this is for controller output. Okay, and the plant output is height and concentration. Okay, you can see here the closed loop response of the CSTR with PID controller. Okay, so this is the step response. I change it from 20.8 to 22, and it is going to be slowly settles the product concentration. It starts from here and settle down to 22. Okay, so the x-axis is the samples. Okay, so participants, with this I finish my today's sessions. Now, if you are having any doubts, means you can ask me. Before that, just uh,
Very good afternoon to all the participants. I am Dr. R. Govindarasu, one of the organizers of the program. It is my immense pleasure to thank our Honorable Secretary, beloved Principal, respected HOD of Chemical Engineering, Sri Venkateswara College of Engineering, Sriperumbudur Taluk, for giving us the opportunity to organize this two-day workshop. I extend my sincere thanks to the speaker of the entire program, Dr. G. Saktivel, Professor of Electronics and Instrumentation Engineering, Annamala University, Chidambaram. He is an expert person in process control and automation. He has delivered wonderful lectures in the past 2 days in Matlab applications in process simulation and control, from basic concepts to advanced applications, which are very much useful and more informative to all the participants. Thank you, sir. Next, I thank all the participants from various parts of the country for their active participation and interaction. Last but not the least, I thank the convener of the program, Dr. N. Mayappan, other coordinators, Mr. D. Sivakumar, Mr. S. Jayganesh, and our active student members, Harish Kumar, Praveen Kumar, Vignesh, and Secretary, who are involved dynamically to organize the workshop and make it in a grand success. Thank you, one and all.
participants, if you are having any doubts, means if you are ask me, I will show the my I will give my mail ID also. Okay, so this is my mail ID. Okay, this is my mail ID and this is my mobile number. If you're having any doubts, means ask me. Or now itself, if you want, means you ask the doubts through chat box. I will try to explain your doubts. Somebody asked if you define the two functions separately, can we give one of the function as the parameter for the other? That's why I told you from the function itself you can call the another function. You can do it. I forgot the name. For the beginners you are asking or a basic. Uh, I will give the link to the coordinators regarding the some short books or materials. It's also available. I will send the materials to you. I'll give the link to the coordinators. You can refer those books. Some of the latest process control books, for example, if you are chemical engineering, if you read the process control book, that is modeling design and simulation by Beckwood, means for all the units they are concentrated, it is going to be on Matlab based. If you are designing the model, how to simulate it by coding and both simulink and coding, they done it. Okay, so from simple level to advanced level they done it. If you are the process control person, means better. If it is the process related queries you are having, if you want to study the MATLAB with respect to the process control, means better you can study the Beckwood book of process control modeling design and simulation. I don't know regarding the online MATLAB editor. I can't understand what is the online MATLAB editor. I don't know. Any other questions? General book. I forgot the author of the book. I will send it to your coordinator. He will mail you regarding the book name. I'll for now timing. I forgot the name of the book. General books are available. Gurumani, you need the book for speech processing. I don't know the author of the speech processing. I don't know the name of the book because I didn't do anything in speech processing. So I hope you didn't have any doubts. Okay. So with this I conclude my session. Good afternoon to one and all the participants. At this time, I place my gratitude to Sri Venkateswara College of Engineering for giving me the opportunity to conduct the online workshop on MATLAB applications in process simulation and control. I thank Dr. N. Mayappan HOD and coordinators Dr. R. Govindarasu, or Mr. D. Sivakumar, Mr. S. Jay Ganesh for giving me the opportunity to conduct this 2-day online workshop on MATLAB applications in process control, simulation and control. I hope you got some information from these two-day workshops, because it is not possible to give you all the information because the MATLAB is like the ocean. So within 2 days you can't study. Just you have the glimpses of what are the things available, commands available, or what are the things you can do for the process control or control system or image processing. Like that you can understand from these things. So I hope you understand some information, some basics of MATLABs from my workshop from my lectures. So again, once again, I thank you all participants and Sri Venkateswara College of Engineers and convener and coordinators for giving me the opportunity to give the lecture for the online workshop. Thank you.